Welcome to this comprehensive guide on C# scene management and asynchronous scene loading in Unity. This tutorial is specifically designed for beginners looking to understand how to create seamless transitions in their games. Understanding scene management is a fundamental skill for any game developer. It's crucial for creating smooth transitions between different parts of your game, such as various levels, menu screens, or other distinct sections. Think of scenes as individual movie sets within your game. Each scene is a self-contained unit that holds specific environments, characters, sounds, and scripts necessary for that particular part of the game. Unity Scene Manager is the core tool that allows you to control these scenes seamlessly. It streamlines and enhances the entire process of managing different scenes, making your game development more efficient. Asynchronous loading is a vital technique because it prevents your game from freezing or becoming unresponsive during scene transitions. This ensures a much smoother and more enjoyable player experience. This method is especially important for larger, more complex games where loading times can be significant. Without asynchronous loading, long waits can severely impact user satisfaction and immersion. The Scene Manager class is the cornerstone of scene management in Unity. It's part of the Unity Engine.Scene Management namespace and is central to dynamically loading and unloading scenes. To utilize its powerful features, you'll always need to add using Unity Engine.Scene Management to the top of your C# scripts where you plan to manage scenes. One of the primary methods is SceneManager.LoadScene. This method loads a new scene, and it can be used to either replace the current scene entirely or add to it. Overloads of this method allow you to specify the loading mode: load scene mode, single or load scene mode, additive, load scene mode. Single unloads all current scenes before loading the new one, effectively replacing the entire game state. Load scene mode, additive loads the new scene alongside existing ones. This is incredibly useful for layering parts of your game. For example, you might use additive loading to have a persistent user interface or a dynamic environment that loads in segments. To avoid freezing your game, SceneManager.LoadSceneAsync is the preferred method. It loads a scene asynchronously in the background. This method returns an async operation object, which is your key to tracking the progress and status of the scene loading process. The async operation object provides two crucial properties: asyncLoad.Progress, a float between 0 and 1 indicating loading progress, and asyncLoad.IsDone, a Boolean indicating completion. SceneManager.getActiveScene is another useful method. It returns the currently active scene, which is helpful for determining context or applying logic specific to the current scene. Now, let's dive into a detailed, step-by-step guide to implementing asynchronous scene loading in your Unity projects. Step 1. Always include the Unity Engine.Scene Management namespace. This is the foundation for all scene management operations. Step 2. Create a coroutine to handle the asynchronous loading process. Coroutines are special functions in Unity that allow you to pause execution and resume it later over multiple frames. Here's a complete example of a scene loader class. This script will manage the loading process, including displaying a loading screen. The class includes public variables: scene to load for the target scene's name, loading screen for the UI panel, and progress bar for visual feedback. The LoadSceneAsync method takes the scene name and stores it, then starts our LoadScene coroutine to begin the background loading. Inside LoadScene coroutine, the very first action is to activate our loading screen game object, making it visible to the player. Step 3. Start the asynchronous operation. This is done by calling SceneManager.LoadSceneAsync with the name of the scene you want to load. Remember to replace scene to load with the actual name of your scene, or you can use its build index if preferred. Step 4. Track the progress of the loading operation. We use a while loop that continues as long as asyncLoad.IsDone is false. Inside this loop, we calculate a progress value. We clamp asyncLoad.Progress and divide by 0.9 because Unity's progress typically stops at 0.9 before activation. This progress value is then used to update our progress bar.fillAmount, providing a smooth visual indication of loading to the player. Crucially, yield_return_null pauses the coroutine for 1 frame. This allows the game to continue processing other tasks, preventing it from freezing. Once the while loop finishes, meaning asyncLoad.IsDone is true, the scene has fully loaded. At this point, we deactivate the loading screen. Step 5. Implement a loading screen. This is highly recommended to provide visual feedback and improve the player experience during loading. As shown, you activate the loading screen before starting load scene async and update its progress bar using the async operation .progress property. After the scene is fully loaded, you simply deactivate the loading screen to transition smoothly to the new game content. Step 6. Handle scene activation. By default, Unity automatically activates the scene once it's loaded. However, you can prevent this immediate activation by setting async load that allows scene activation equals false. This allows you to perform additional tasks, such as displaying a press any key to continue message before the new scene becomes fully interactive. When you're ready for the player to enter the new scene, simply set async load that allows scene activation equals true. Now, let's explore some additional tips and best practices to further optimize your scene management and asynchronous loading. Tip 1. Design modular scenes. Aim for scenes that are independent and focused on a single purpose. This approach promotes reusability across your project and significantly improves scalability, making your game easier to manage and expand. Tip 2. Utilize additive loading for dynamic content. This allows you to load different level segments or environmental elements without unloading the current scene. This technique is perfect for open-world games or games with evolving environments, where you want to stream in content as needed. Tip 3. Always ensure all your scenes are added to the build settings. You can find this under File, Build Settings in the Unity editor. The order of scenes in the build settings determines their build index, which can be used as an alternative to scene names for loading. Tip 4. Be mindful of memory management. When a single mode scene is loaded, Unity automatically calls resources.unload unused assets. This automatic cleanup helps free up memory from assets no longer needed. But for additive scenes, you might need to manage this manually. Tip 5. Organize your C# code. Use regions in your scripts to logically group variables and methods. This practice makes your code much easier to read, understand, and maintain, especially as your project grows in complexity. Tip 6. Follow clear naming conventions. Use descriptive names for your scenes and game objects. Avoid using similar names for different assets, as this can lead to confusion and errors during development. By diligently following these guidelines, you can effectively manage scenes in your C# Unity projects and implement robust asynchronous loading. This will not only streamline your development process, but also create a seamless and engaging player experience, which is crucial for any successful game. Thank you for watching this tutorial on C# scene management and asynchronous scene loading. We hope this guide helps you build better, more immersive games.